You are standing on the shoulder of an American interstate in 1955. A convoy of Mack trucks rolls past you. Over 1 in 3 of those trucks is running the same engine. An engine that landed infantry on the beaches of Normandy, drove Sherman tanks across France, powered tugboats on the Mississippi, and ran fishing fleets out of New Bedford. 5 million units built. 40% of the American heavy-duty market at its peak. The loudest engine ever to run on an American highway. By the early 1990s, every on-highway version of it had been pulled from production. The interstates went quiet inside a decade. This is the story of the Detroit Diesel Series 71, the Screaming Jimmy, and it starts with one engineer refusing to let his own committee kill it. Part 1. The architecture nobody believed in. In 1930, American heavy transport ran almost entirely on gasoline. Diesel engines existed, but they were a European technology, built around the 4-stroke cycle Rudolf Diesel had patented back in the 1890s. Those engines were heavy, complex, and unforgiving. A 4-stroke diesel needed a precision injection pump, a complicated valve train, and a mechanic capable of rebuilding a fuel system under near cleanroom conditions. None of that was practical in a fleet yard in Cleveland or a railway maintenance shed in Kansas City. One man at General Motors believed the entire architecture was wrong from the ground up. Charles F. Kettering was the head of General Motors Research in 1930, a self-taught Ohio farm boy, 63 years old at the time, carrying the kind of institutional credibility that only comes from being right about machines nobody else believed in. He'd invented the electric starter motor, the device that ended the hand crank, a mechanism that had hospitalized more drivers in the early 20th century than the cars themselves ever did. His fingerprints were on the diamond ignition system, leaded gasoline, Freon refrigeration, and the diesel locomotive engine that would eventually push steam off American railways entirely. He had the ear of the GM board, and a track record of backing engineering judgment against the accountants and winning. What he didn't have was unlimited credit. Kettering's proposal for diesel was a completely different architecture. A 2-stroke, not a 4-stroke, meaning a power stroke on every single revolution of the crankshaft instead of every other revolution. A simpler valve train, and critically, modular construction, a family of engines from 2 cylinders all the way up to 16, all built using identical pistons, identical liners, and identical injectors throughout. Field strippable with hand tools by any competent mechanic anywhere, there was a problem. Every previous 2-stroke diesel anyone had built had failed. They smoked, they fouled, they self-destructed inside 1,000 hours of running. The GM Engineering Committee had heard Kettering pitch this exact concept before, and they were not enthusiastic about hearing it again. The prototype failed. The specific problem was scavenging. In a 2-stroke engine, exhaust gas has to leave the cylinder in the same fraction of a second that fresh air enters it. Get the internal geometry wrong, and the 2 gas streams mix together. The cylinder fills with hot exhaust diluted by cold incoming air. Combustion goes ragged. Black smoke pours out of the stack. Power collapses the moment you put the engine under real load. Kettering's team ran 2 revised port geometries. Both of them failed too. What the GM Engineering Committee saw when they reviewed the test reports was a research program spending real money during the Great Depression to confirm exactly what they'd already suspected going in. The Indianapolis test cell logs stood as a documented record of failure across 2 full configurations and most of a third. Every other division of the corporation was actively cutting headcount at the time. The committee reviewed the program and formally recommended termination. Kettering refused to accept that recommendation. He asked for one more configuration. Part 2. Uniflow scavenging the breakthrough. The solution arrived between 1935 and 1938. It's called Uniflow scavenging. Fresh air enters the cylinder through ports cut around the bottom of the liner. Exhaust exits through valves positioned at the top of the head. Air and exhaust move in a single direction bottom to top, and critically, they don't mix. A Roots-type supercharger, geared directly off the crankshaft, forces air through the cylinder under pressure. For the first time in the program's history, the engine breathed cleanly. The first running prototype with Uniflow scavenging produced clean exhaust at full load, a stable idle, and a power curve that European four-stroke diesels simply could not match for the same displacement. The same engineering committee that had voted to terminate the program back in 1934 signed off on the production budget in 1937. The GM board approved full development. General Motors' diesel division was formally established in 1938. The first product was the Series 71, the name referring to 71 cubic inches of displacement per cylinder. It launched in inline 2, 3, 4, and 6-cylinder configurations, and all four shared the same bore, the same stroke, and the same pistons. A mechanic who could service one variant could service every variant. A parts depot that stocked for one, stocked for all of them. It was the closest thing American heavy industry had ever seen to a genuinely modular diesel platform. Between 1938 and 1941, the engine took hold across the market. Fleet operators sent back fuel consumption and reliability numbers that the gasoline competition simply could not match. A Series 71 running in a city bus operated for 800 hours between maintenance intervals. A comparable gasoline engine ran roughly 200. Greyhound's mechanics in Chicago noted that these engines didn't lose compression the way spark ignition units reliably did over time. Long-haul truck operators in Texas and California were writing letters back to Detroit asking how soon they could place orders for the next available allocation of the inline six. The Series 71 was doing exactly what Kettering had promised it would do. What it hadn't yet been tested against was a demand no peacetime production flaw could ever have anticipated. Part 3. The War 6,000 Engines a Month. In December 1941, everything changed. By the spring of 1942, the War Production Board, operating under William S. Knudsen, a former GM president who understood exactly what the corporation was capable of executing under pressure, had cataloged every diesel engine in American industry. The list came back short. The Series 71 was the only American diesel that could be manufactured at scale, field-serviced with basic hand tools, and deployed across multiple vehicle types simultaneously. Production climbed steadily through 1942 and peaked at approximately 6,000 engines per month. Picture the plant on Outer Drive in Detroit. Second shift, spring of 1943. The building didn't feel like a factory anymore. It felt like a foundry that had been told to run faster than it was ever built to run. The smell hit first, hot iron off the casting floor, the burnt sugar edge of two-stroke exhaust from test cells running engines around the clock. Conveyor belts moved cylinder blocks past inspection stations staffed almost entirely by women. By 1943, the men were overseas gauging bore tolerances down to the nearest thousandth of an inch. The noise was the constant percussion of stamping presses, horizontal mills, and the rising scream of a 671 being run up on the test stand through its acceptance dynamometer cycle before being crated and shipped out. Every engine that left that plant was going somewhere a soldier or a sailor needed it to actually work. The Marinized Gray Marine 671 powered the LC, the Higgins boat, the flat-bottomed plywood landing craft that put American infantry onto beaches from Normandy to Tarawa. The M4A2 Sherman tank ran the GM 6046 two inline 671 engines bolted side by side, sharing a single output shaft. That was Kettering's modular architecture, doubled, because the military trusted the engine enough to multiply it rather than commission something new from scratch. The supercharger whine at high RPM, a rising mechanical scream that carried across water, over hills, and through coastal fog is what gave the engine its name. The soldiers and sailors who worked around it called it the Screaming Jimmy. If you've never heard of the Screaming Jimmy before this video, hit subscribe. We're building the largest archive of industrial and automotive history documentaries on YouTube. Back to the story. Part 4. The post-war decade becoming the sound of American freight. When the war ended in 1945, surplus engines flooded the civilian market, and Detroit diesel captured the post-war commercial landscape almost immediately. The inline 671 came first, followed by the 6V71 starting in 1957 once the V-block family arrived. Mack Truck specified the 12V71 for its heaviest haulage applications. Tugboats up and down the Mississippi ran on them. Fishing fleets out of New Bedford ran on them. Offshore rigs in the Gulf ran on them. The V-block family arrived in 1957. The 6V71, 8V71, 12V71, and 16V71 extending Kettering's modular logic into a V configuration without abandoning the shared parts catalog that made the whole family serviceable as one system. Same heads, same liners, same injectors across the range. In 1965, the division was renamed the Detroit Diesel Engine Division. In 1970, it merged with Allison Transmission to form Detroit Diesel Allison. This was the division at peak institutional weight inside General Motors. By the mid-1950s, on a typical American interstate, over 1 in 3 heavy trucks rolling past you was running a Detroit diesel engine. The engine wasn't the smoothest on the road, and it wasn't the quietest. The supercharger drone at idle was loud enough to set a coffee cup vibrating on a roadside diner counter from 40 feet away. What it offered in exchange for the noise was the closest thing American freight had ever known to a guaranteed working day. A 671 would start in a Wyoming winter at minus 30 degrees. It would run on diesel cut with almost anything that poured. It accepted maintenance from a mechanic with nothing more than a tool roll and a service manual. Drivers learned its language. They knew when a bearing was heading out by the sound alone. They knew which injector was fouling by a change in the exhaust note over a specific gear change. The engine talked to them. They listened. Part 5. October 1973, the day the arithmetic changed. On October 6, 1973, Egyptian and Syrian forces crossed into Israeli-held territory. The American trucking industry recalculated everything overnight. Pump prices moved from roughly 38 cents per gallon toward a peak near 84 cents. Fuel, which had always been a secondary line on a fleet spec sheet, something you answered after horsepower, after torque, after reliability, was suddenly the first question and the last question in every conversation. For a national carrier running 1,500 trucks at 500,000 miles each per year, a 1 mile per gallon difference at prevailing diesel prices was the difference between profit and loss across an entire operation. This wasn't subtle arithmetic. A fleet manager who'd specified a Screaming Jimmy in 1972 because of its power-to-weight ratio was now sitting across the desk from a corporate controller demanding to know why the same fleet was spending 20% more on fuel than the company across town running Cummins engines. This is exactly where the two-stroke architecture's structural weakness turned fatal. Because the engine fired on every single revolution, it depended on a mechanical roots blower to continuously force fresh air into the cylinders. That blower was geared directly off the crankshaft. It was a parasitic load-stealing horsepower straight off the crank before it ever reached the transmission. At partial loads and steady highway cruising speeds, the thermal efficiency of a two-stroke simply could not match a four-stroke design. At the exact moment the American market changed permanently, Detroit Diesel's engine remained the most powerful heavy-duty diesel on sale in the country. Power was suddenly no longer what the market was buying. Part 6. The decision that cost 13 years. Inside Detroit Diesel's engineering division in 1973 and 1974, a clear-eyed internal paper existed. The efficiency gap between the two-stroke and its four-stroke competitors was fully documented. The parasitic load of the blower was quantified in hard numbers. The incoming EPA emission standards were modeled, and that modeling was unambiguous. The two-stroke architecture carried an inherent emissions problem baked into its basic design. Because oil rings had to continuously pass over open intake ports cut directly into the cylinder walls, tiny amounts of engine oil were swept into the combustion chamber and out through the exhaust stream on every single cycle. Managing that oil migration while simultaneously trying to lower combustion temperatures to reduce nitrogen oxides without producing excessive smoke in the process was an engineering problem with no clean solution inside a two-stroke configuration. The four-stroke architecture, with its sealed crankcase and fully independent intake and exhaust strokes, was going to comply with EPA standards more cleanly and more cheaply. Full stop. The engineering floor stated their position clearly. A four-stroke development program needed to begin immediately, running in parallel with the Series 92, or Detroit Diesel would spend the next decade fighting the next market with the previous decade's engine. The Series 92, a larger two-stroke V-block, more displacement, more power. The same architecture, simply extended along its own established logic, had already been in development for years by this point. Most of the capital was already committed. Supplier agreements were locked in. Tooling was purchased and paid for. From inside a boardroom in early 1974, walking away from the Series 92 meant writing off a major capital commitment based on a crisis that institutional consensus still expected to be temporary. In 1974, the Series 92 launched exactly as planned. The four-stroke program did not get funded. Detroit Diesel's four-stroke replacement, the Series 60, would not arrive until 1987. The gap between what the engineering floor had documented and what the institution actually decided to do about it. Part 7. The erosion carrier by carrier. Contract by contract. The EPA dimension arrived in waves through the late 1970s. Federal emissions standards for heavy-duty diesels tightened on a fixed schedule, and every single tightening parameter was one the two-stroke architecture handled least well of anyone in the market. Uniflow scavenging the exact engineering breakthrough that had made the engine viable in the first place, back in 1938, was now the direct source of its compliance failure. Four-stroke competitors met each new standard at a lower engineering cost. Every time, Detroit Diesel found itself fighting on two fronts simultaneously: fuel economy on one side, emissions compliance on the other. Every modification the engineers made was a patch on an architecture the engineering floor had already told management back in 1973 would not pass the regulations being modeled. None of the modifications produced a clean compliance margin. They produced just enough to ship the next model year, with the next regulatory cycle already visible on the horizon. Cummins launched the Big Cam series in 1976, and the marketing was targeted with surgical precision directly at Detroit Diesel's existing fleet customers. The advertised numbers weren't horsepower figures. The advertised numbers were cost per mile fuel economy, expressed in the exact language fleet managers actually spoke. Cummins salesmen were sent directly into accounts that had run Screaming Jimmys for 20 years, with explicit instructions to come back with signed renewal contracts. A national carrier ordered 50 Cummins-powered tractors in 1976 to evaluate alongside its existing Detroit diesel fleet. The fuel logs came back 12 months later showing measurable improvement. On the next replacement cycle, that same carrier ordered 300 Cummins units. The cycle after that, 900. Multiply that exact pattern across every major carrier in the country, and the result landed on a Detroit Diesel sales director's desk in 1981 as a market share figure that told the entire story on its own. Caterpillar ran the identical playbook out of Peoria, Illinois. The four-stroke architecture both companies had been quietly refining since before the embargo was now the only answer to the only question the market was still asking. By 1988, Detroit Diesel's market share had fallen to approximately 3 to 4% of the American heavy-duty truck engine market. Part 8. The capital trap inside General Motors in the 1980s.
Through the 1980s, General Motors committed approximately $50 billion to plant and product modernization across the entire corporation. Industry analysis suggests something on the order of $100 million of that total actually reached Detroit Diesel. While the passenger car divisions absorbed capital to fight off the incoming wave of Japanese imports, the heavy-duty division, a captive internal supplier with no independent commercial mandate of its own, waited for funding that never fully arrived. Engineers who had joined the division back in 1969, specifically because it was the best diesel program in America, watched their best proposals sit waiting for budget approvals that got deferred year after year. Some of them left. Some stayed because they believed the corporation would eventually recognize what it was losing. The ones who stayed were still there in 1987 when the Series 60 finally launched. They built it. The corporation that had owned them for 13 years was not the reason it turned out as good as it did. Here's the genuinely painful part of this whole period. The engineers who built the Series 71 back in the 1930s, the same people who spent 3 years solving the scavenging problem against the explicit recommendation of their own committee, were exactly the kind of engineers who could have built the four-stroke replacement back in 1975. The institutional capacity was there the entire time. The skill was on the floor the entire time. What wasn't there was institutional permission to start. The same corporation that gave Kettering one more configuration in 1937 could no longer hear its own engineers in 1974. Part 9. The Series 60 and the Penske acquisition. In 1987, Detroit Diesel launched the Series 60. Four-stroke, 12.7-liter displacement. It was the first heavy-duty diesel engine sold in America, with fully integrated electronic engine management, real-time fuel mapping across the entire operating range. Initial horsepower at launch ran between 360 and 400. It wasn't designed as a power statement. It was designed as an efficiency statement, which was exactly what the American trucking market had been asking for since October 1973. It arrived 13 years late. Roger Penske entered the story in 1987, carrying a public profile most people at the time associated with the Indianapolis 500 and kart championships. His real expertise, though, was operational. Penske Truck Leasing ran tens of thousands of vehicles across North America and understood a diesel engine exactly the way a fleet manager understood one, as a cost-per-mile figure calculated across the full service life of a contract. When Penske examined Detroit Diesel in 1987, he saw a company that had just launched a genuinely competitive new engine, still retained a deep and experienced engineering workforce, and held a depressed market share with essentially one direction left to go, provided it was run as a standalone competitive business rather than as a captive supplier inside a corporation that had effectively stopped funding it. Penske's team worked through the Series 60's full bill of materials, its warranty curve, its tooling depreciation schedule, and its per-unit margin across 3 separate volume scenarios. They modeled what the engine could actually do if it were sold by a company whose entire commercial existence depended on selling it successfully. The number they arrived at was a business that would be structurally healthy at 1.5 times the 1987 market share and structurally dominant in its segment at 4 times that share. In a deal reported at approximately $300 million, Penske acquired 60% of Detroit Diesel in 1988. General Motors retained the remaining 40%. The structural conditions that had produced the decline, captive supplier status, internal capital competition, passenger car divisions always taking priority on funding calls, were removed the moment ownership changed hands. Detroit Diesel was now accountable to exactly one thing: its own market performance. If you drove behind a screaming Jimmy, worked on one, or grew up listening to your father talk about the engine that built his working life, drop a comment. Which engine? Which truck? Which job? We want those records preserved. Hit subscribe. We're building the largest archive of industrial and automotive history on YouTube, and the workforce that built 5 million of these engines deserves to be remembered properly. Part 10. The Turnaround and the End of the Screaming Jimmy. The Penske turnaround was fast, and it was structural. Market share climbed from that 3 to 4% floor in 1988 to approximately 33% by 1993. The mechanism was focus. All engineering resources went to the Series 60. The Penske truck leasing fleet became a direct sales channel. Suppliers that had been carried for years purely on the strength of the GM relationship were renegotiated against genuine benchmark pricing. The sales organization was rebuilt around fleet account management rather than the dealer network that had served the captive supplier era. Engineering resources that had been tied up servicing the legacy 2-stroke fleet were redeployed toward landing new Series 60 specifications inside major carriers' upcoming replacement cycles. The Series 60 finally reached the market the way it needed to, because for the first time in 15 years, it was being sold by a company whose entire commercial purpose was selling it. Within just a few years, as stricter federal emissions deadlines arrived in the early 1990s, on-highway 2-stroke production was permanently phased out. The screaming Jimmy, as the standard sound of American commercial roads, fell silent on the interstates. 2-stroke production continued for marine, military, and stationary applications. The Series 71, Series 92, and the larger Series 149 rolled off specialized production lines well into the following decade for legacy customers. In the truck stops where you used to hear one coming from a quarter-mile away, the engine that had defined 40 years of American freight was finished. In 1993, Mercedes-Benz took an 11% stake in Detroit Diesel. In 2000, Daimler Chrysler acquired the company outright. Detroit Diesel became part of Daimler Trucks North America. The Detroit brand survives to this day. The DD13 and DD15 are powering American trucks right now. The Series 60 itself was discontinued in 2011 and replaced by the DD15. The Screaming Jimmys live on in restored trucks at vintage rallies, in the engine rooms of working fishing boats that never quite earned their refit budget, in tugboats on rivers where nobody's watching the emissions calendar. The architecture retreated rather than collapsed, and in some ways that makes it harder to say exactly where it ended and harder to fully mourn. Part 11. The Series 60 in service. What the fleets actually found. Numbers on a spec sheet are one thing. What a fleet finds after 500,000 miles is another. And it was the second number that decided the outcome. Carriers running the Series 60 through the early 1990s reported something the two-stroke generation had never delivered, a genuinely predictable overhaul interval, where a well-maintained Screaming Jimmy might need major work well before 400,000 miles. Series 60 units in line-haul service were routinely running past 700,000 miles between overhauls, with some documented fleet examples pushing beyond 1 million miles on the original bottom end. For a fleet operator, that number doesn't read as an engineering achievement. It reads as a maintenance budget line that just got smaller, year over year, contract after contract. The Electronic Engine Management System, Detroit Diesel Electronic Controls, referred to across the industry simply as DDEC, was the other half of the story, and it mattered in a way that had nothing to do with horsepower. DDEC let a fleet manager see, for the first time, exactly how an individual driver operated an individual truck. Idle time, shift points, fuel burn per mile, hard braking events. Fuel was the single largest controllable cost in a trucking operation, and DDEC turned it from a number you discovered at the end of a quarter into a number you could manage in real time. Fleets that adopted driver coaching programs built around DDEC data reported fuel economy gains that, multiplied across a few hundred trucks running a few 100,000 miles a year, dwarfed the sticker price difference between engine brands entirely. This is the part of the story that rarely makes it into the nostalgia. The Series 60 didn't just replace an engine, it replaced an entire way of managing a fleet. The two-stroke era had been mechanical, analog, and dependent on a driver's ear and a mechanic's experience. The Series 60 era was the first moment the American truck became a data-generating asset. Every heavy-duty engine built after it inherited that expectation. There was no going back to an engine you couldn't interrogate. Part 12. What survived, and why it still matters. Walk into a Detroit diesel remanufacturing shop today, and you will still find Series 71 blocks on the bench. Not as curiosities, as active inventory. The two-strokes mechanical simplicity, no camshaft-driven valve overlap to manage, no electronic architecture to fail in a saltwater engine room, is precisely why the marine and military markets never fully let it go. A Series 71 in a fishing boat doesn't need to pass an EPA highway test. It needs to start every single morning in a cold engine room with minimal specialized diagnostic equipment on board, and that is a job the two-stroke architecture still does better than almost anything built after it. The collector market tells the same story from a different angle. Restored Detroit diesel-powered trucks routinely draw crowds at vintage truck shows specifically for the sound, that distinctive two-stroke wail that gave the engine its nickname in the first place. It is, by a wide margin, the most immediately recognizable diesel exhaust note in American automotive history. No four-stroke engine, however well-engineered, has ever replicated it, and none ever will, because the sound was never a byproduct of the design. It was Uniflow scavenging itself, made audible. There is a broader lesson here, and it is worth stating plainly rather than leaving it implied. The Screaming Jimmy did not lose to a better engine in 1974. It lost to a regulatory and financial environment that changed faster than a captive division inside a distracted corporation could respond. The Series 60, when it finally arrived, proved the engineering talent had never gone anywhere. What had been missing was 13 years of institutional will. That is not a story about diesel engines. That is a story about what happens to good engineering inside a company that has stopped listening to its own engineers. And it is a story that has repeated itself, in different industries, more than once since. If this is the kind of engineering history you want more of, hit subscribe. We're building the largest archive of industrial and automotive history on YouTube. Drop a comment with the engine, the truck, and the job. We're reading every single one. I'll see you in the next one.